All right, good afternoon. My name is Jingyan. I'm presenting my work, The More You Look, The More You See, General Object Understanding Through Recursive Refinement. This is joint work with Olga Russakovsky and Deva Ramanan at Carnegie Mellon University. In object detection, we believe it's important to understand the details of the objects, more than their categorical labels and bounding boxes. For example, here's a person, but we want to ask more questions about this person, such as, is he facing the camera or not? Where are his arms and legs? What is his pose? And so on. We call this ability of answering different types of questions as general object understanding, and this is a task we consider in this work. Before I describe our approach, let's first consider a simple baseline, and that's multitask learning. In this case, we separately train a classifier for each of the tasks or questions separately. And during test time, we run each of the classifiers separately to answer the different questions. This is simple, however, it has notable issues. First, in order to train these classifiers, it requires exhaustive annotations across all tasks and all examples in the training set. And second, because the classifiers are trained separately, it doesn't scale to a large number of tasks or classes. And third, we can't add new tasks on the fly without training new classifiers for the new tasks. Now I'm gonna introduce our model to address these issues. First, to avoid exhaustive annotations on the training set, we propose to cluster the training object into subcategories. And on the task image, we first detect the subcategories and do the label transfer step. So going back to the same example, instead of running multiple classifiers, we just predict the cluster that this task image belongs to. In this case, it's a standing person. So we pull any training example from the same standing person cluster and transfer its labels back to the task image. The labels can be anything. Here I'm showing some examples for the instance mask, for the part masks, and for the key points. Second, to scale to a large number of classes, we propose to build a semantic hierarchy. So now instead of directly predicting the subcategories, we first predict if the region contains an object or not. The answer here is yes. So conditioned on there's an object, we now look at what type of object it is. We know it's a person, and because it's a person, there is no need to look at the subcategories associated with other classes, such as dogs, cats, etc. And now we only need to focus on the subcategories of people. Finally, again, we know this is a standing person. By having this hierarchy, we are able to prune redundant computation, and that's why our method is more efficient. Finally, we interleave localization with classification. To start with, we have sliding windows or any proposal-based method. We have sliding windows or any proposal-based method. And again, we first decide if there's an object or not. The answer is yes. Here, we relocalize the bounding box and re-extract the features. From the re-extracted features, we now ask question of what type of object it is. It's a person, and because it's a person, now it's much easier for us to relocalize the bounding box because we can look at clues specific to people, such as the body parts. So we re-extract the features and relocalize the bounding box again. Finally, we decide as a standing person, we relocalize the box again to make the results most accurate. This is conceptually very simple, and if you think about it, this is essentially an extension of the faster RCN model to multiple stages in a hierarchy. Finally, we do the same label transfer step again, and this concludes the description of our model. In our experiments, we first detect the subcategories on the test set on the left. And from the clusters our model predicted, we can pull training examples as shown on the right. We can see there is a good correspondence between the training and the test objects. So this is why we can transfer labels from the training set to the test set. I'm showing results for instance segmentation here, for part segmentation, and key point detection. For quantitative results, I invite you to see our poster tonight. Finally, to summarize, we propose to integrate semantic search and spatial search in a detection pipeline for general object understanding. The semantic search is by building the hierarchy, and the spatial search is from recursively localizing the bounding box. Thank you.